Hello, everyone. I want to ask before I start, who of you has ever worked on a web application that needed to handle file uploads? Okay, most of you. So I think this is a really common requirement in web applications, but I feel like that it's not talked about enough. And today I want to share with you some of the best practices that I learned over the past few years of being in this field. So a bit about me. My name is Janko Marohnic. I'm from Croatia. I'm a Ruby of Rails developer and creator of the Shrine file attachment library. So most of you have probably used one of these libraries on the screen, and I think that the Ruby ecosystem is really nice that it has so many options which have so many features, which I haven't really been able to find that much in other languages when I researched it. And I personally started my journey with paperclip, and then soon I got a bit frustrated with having to keep everything, all of the file uploading logic in my active record models. So I switched to carrier wave, which let me move it to external classes. Then after some time of using it, I realized that some of the essential features of carrier wave are not really built into the gem, such as direct uploads and background processing. And both of these features are provided by external gems, but they don't work well, and they don't work well with each other. So that also frustrated me. And then around that time, the original author of Carrier Wave released Refile, which really drew my attention because of its simplicity, and I really liked how it solved uh, some of the complexity that Carrier Wave had. So I switched to that, and I was accepted as a core maintainer of Refile. And for a while it was good, but I felt like it was too opinionated, and I think it even says in the README that it's opinionated, that it doesn't work for everyone. And I don't want that. I want something that works for everyone. I didn't see the reason why we needed to sacrifice certain things. So because wasn't really able to find a good way to extend it, I effectively forked off of Refile and created Shrine. About almost 3 years after Shrine was released, Rails 5.2 was released, which featured active storage. So some of the philosophies that I had when building Shrine was that I wanted it for it to work for any Ruby application. This is because I really enjoy working with other Ruby web frameworks, and I have been doing so for the past few years. And I want to focus my energy around tools that everybody can use, not only Rails developers. The way to achieve that, one first component of achieving that is to build for Rack instead of for Rails, because that way Rack is the basis of all Ruby web frameworks. So if you build something for Rack, it's usable everywhere. And another important thing is that I didn't want to couple the implementation to any specific ORM. I think that also leads to better design, because I don't think that file uploads are. I think file uploads should have a thin integration between the persistence layer, but I think it should be usable with anything else. I also wanted like a modular solution so that I can pick and choose the features that I want and modify the behavior. And I wanted to have multiple levels of abstraction, meaning that if I don't like how something works, I want to be able to drop a level lower and use some lower level APIs, still provided by the library, to build the flow that works for me. And I wanted everything to be configurable, because the nature of file uploads is that if a user cannot adjust something to work exactly the way that they want, for example, to reduce the amount of copying of files, then the performance can really suffer because it often involves HTTP requests and whatnot. And I also didn't want any DSLs. I wanted like just simple Ruby configuration. I want to start off by talking about metadata and validation. So you should validate both on the client side as well, but definitely on the server side, the files uploaded by the user. This is an example of how you can validate with Shrine. This particular example validates that the file is not larger than 10 megabytes and that it's a JPEG or PNG image. And the library that you use should support validations. There is a specific caveat about MIME type. When we upload the file to our Rails or Ruby app, the content type header that's received doesn't have to necessarily match the MIME type of the file. This is because the browser determines this value solely based on the file extension. So a person who wants to upload a malicious file can just put an extension that our application considers valid. What we want is to validate to determine the MIME type from file content. And this is possible because each of the file type has something called magic bytes, which is a certain specific bytes, sequence of bytes at the beginning of the file that uniquely determines the type. The most popular tool in Unix for doing that is the file command, but we also have some Ruby gems that can do the same thing. In Shrine, you can enable determining MIME type from the file content by loading the plugin and choosing the analyzer that you want. Another caveat is related to the file size. It's not enough only to validate that because as people, especially people from Evil Martians who introduced me to that idea, they let us know that it's possible to generate an image that is small in file size but large in dimensions, and that can crash our image processing tool. So yeah, so for example, this is an example of like there is a website where the person attempted to generate the most extreme example, and this is something that's called image bomb. And yeah, so we should validate in addition to file size, we should also validate dimensions. And here we can see that the validate block is not a DSL because we can use regular conditionals. And like in this case, it makes sense to validate dimensions only if the type of the file is an image. Otherwise, there's probably no dimensions to extract. With Shrine, it's also possible to extract and validate any custom metadata without the need for any external Shrine extension that needs to hook up to its internals. This is an example of extracting the duration of a video, and then in this block we just write our own custom validation. Every metadata that we extract should ideally be persisted in the database so that we can later extract it from the views. So to recap what we just talked about, you should validate the files that you have. It can be like common extensions, a common metadata, or any custom metadata specific to the type of the file. And you should ideally persist the extracted metadata. Now that we've successfully validated the file, we usually want to process them to normalize it into some formats that our application understands. For image processing, most file attachment libraries come with their own macros, because using image magic is not it's not as convenient, because you usually want to have some kind of macros which are specific to, which have some common web resizing logic. So with Shrine, I didn't want to implement another homegrown solution into Shrine, so I created a separate gem which has a functional approach. So you give it a source image on the input, and it returns the process file on the output. And when we see the command that it generates, we can see that in addition to resizing, it also has some few specific extras, like auto-rotating the image if it's rotated. And also, many of you might not know that after we resize an image, that it gets a bit blurry. So it also applies some additional sharpening. And it's nice to be able to use a tool that takes care of these details for you. There is an alternative to ImageMagick, which is called libvips, or vips for short. And it's really cool because it's often much faster than ImageMagick, and it's also full-featured. So the image processing gem provides the integration for libvips as an alternative backend to Minimagick. It tries to share as much of the same interface as possible. And the example, when I benchmarked generating a 500 times 500 thumbnail, the performance difference was astounding. It was 3 times to 5, libvips was 3 times to 5 times faster depending on the size of the source image. This is a huge performance difference. And I think this is largely due to the fact that libvips supports a much narrower range of formats compared to ImageMagick. So I think it also gives it more focus. And I would also encourage anyone interested more to go and read about the documentation of libvips, which explains some of its internals. Now, the way to actually hook up the processing is the easiest way is to process the images or the other types of files on the fly. This means that when the file is uploaded and we generate a URL for it, when that URL is requested, then the file actually gets processed and typically cached into some CDN. The way that Active Storage and some other gems solve it is to encode the processing steps into the URL, which is convenient because then you don't need to define anything else. However, I don't like this approach because then your URL grows with your processing logic. And also it's not so flexible because you cannot always represent processing as a Ruby hash. Sometimes if you're compositing, you need blocks or something which cannot be serialized into the URL. The approach that Shrine takes is to you define a custom alias and some custom arguments that you want to pass from the view. And then when the URL is hit, the Shrine finds the corresponding processing block that you defined, which is just a simple Ruby block. You can define processing there in any way that you want. And it's nice that when you look at the URLs that it communicates to you what the URL does. So in contrast to having base 64 encoded data only, you have some kind of communication what the URL is supposed to do, what kind of file type is supposed to return. An alternative to on-the-fly processing, which is often common for larger files, such as videos, which cannot feasibly be processed on the fly, is to process on upload, which in Shrine it looks the similar way to on-the-fly processing. You also define a Ruby block, and then you add the result of the block is a collection of processed files that you want. And unlike some solutions like CarrierWave or Paperclip, these files that are uploaded are actually serialized and stored each individually into the database, so that when you later retrieve it, it's all done and ready. So that when you change, you decide you want to change how you generate the upload location, that it doesn't invalidate all of the existing URLs, because the upload location is encoded into the database. Because this is a generic block, we can perform inside any other type of processing. And again, without needing to define any, without needing to use any external Shrine extensions which have to know about internals. So this is an example of transcoding a video. So to recap processing, you can do it either on upload or on the fly. On upload means that it's triggered when the file is attached. On the fly when the URL is requested. For image processing, it's good idea to use the image processing gem, and this is something that Active Storage now uses as of Rails 6.0. Which has a minimagic wrapper and a libvips wrapper, which is oftentimes much faster. Now that we've successfully validated and processed our files, let's go back and improve the user experience of uploading the file itself. So what I mean is that we want to go from like a synchronous upload where the user doesn't know like how long something will it will take for the image to upload or any other type of file. Is we want some kind of like more asynchronous experience where, for example, user can edit other fields and whatnot. Some file attachment libraries, such as Active Storage and Refile, they solve this problem by providing their own JavaScript file, which automatically hooks everything up. But I didn't like this approach in Shrine because I think it needs to be customized a lot, and people will come up with new features, and then I need to worry about browser compatibility and everything, and I just didn't want to maintain that, and so I discarded that. But luckily, the JavaScript ecosystem have solved file uploads, so we can use one of the JavaScript packages for that. At the time when I created Shrine, these were the most popular available option, but I found each one to be really difficult to use and configure to work with a simple flow that I wanted for Shrine. So these solutions I wouldn't recommend. Okay. So the solution I would recommend is called API, which is a relatively new and modern JavaScript solution for file uploads. And I was really happy when I researched it that it already hooks really nicely into the existing Shrine components. So it knew about a lot of stuff that the other JavaScript libraries didn't. So what's cool? One cool thing about it is that it comes with built-in UI components. Such you can just start from a simple file input and a progress bar, which looks like this. And by the way, the previous progress bar that I generated was I had to implement it using Bootstrap, but this one is provided along with CSS and everything by API. So the next level could be a drag and drop field and a status bar which shows like more information. And you can even also have like a full-blown dashboard that combines a lot of these UI components and provides a really nice user experience. And this is all provided out of the box from API. And as you might have seen from the code, API is also modular, so you can or you don't have to choose these UI components if you don't want to. So this was only presenting how the API will present the file upload itself, but I want to talk about how to actually we need to tell it where to upload the files. The most simple solution is to just give it some custom endpoint where it can upload the file, and then that endpoint can then forward that file onto the storage on your app, and just return some JSON data representing that file. And then when we submit the form, we only submit the JSON data, so the submit is instantaneous. We utilize that by loading the corresponding API plugin and just point it to the URL that we want. And then on the backend side, Shrine provides a complete endpoint which will do the uploading and returning the response for you. So you can also mount it wherever you want in your router. And by the way, this is not Rails specific because that component is built with Rack, so it can be used in any web framework. Now this solution is the simplest, but it is your server, your application still needs to handle the actual upload itself, which is using some resources. An ideal thing would be to upload directly to a cloud service like S3. And the flow looks a bit like this, that the client first needs to fetch upload parameters from the server, because these upload parameters need to be generated from the AWS keys, which only live on the server. And then the browser can use that data to make the actual upload. And then again, just when the form is submitted, only the JSON data is sent via the form. The flow looks similar. We just load a different API plugin. And what's nice is that API already knows about this flow. It already knows about fetching parameters from the application and then uploading it. So it will do the AJAX calls for you. You just need to tell it where to look, and then just define a route for that, which will generate the actual upload parameters, which Shrine again provides for you. So to recap, direct uploads, you can do it. The simplest way to do it is just an endpoint on your app, but you can also do it directly on S3 or like another cloud storage service. This usually provides better UX and performance. I recommend that you use API regardless of whether you're using Shrine or something else. It's really nice because it has built-in UI components and has really easy direct uploads to S3, which I haven't found in other solutions. And it has like numerous more features, which I encourage you to check out. Now we can, if we're uploading large files, we can extend upon our direct upload flow and improve the user experience even further by making the uploads resumable. So the problem with simple uploads is that it's just a single HTTP request. So this HTTP request, the request body is the file content. So if that request gets interrupted at some point, for example, due to a flaky connection, then the uploads needs to be restarted from the very beginning. And this might range from like a simple annoyance from your user, but also to some people might not even have access to good internet. So if they're uploading sufficiently large files, their internet connection might not last long enough for the whole file to get uploaded. The way to solve this is to split the upload into chunks, so that then each of these chunks is uploaded individually. So if one of them fails, only that chunk can be retried. And also in some cases, multiple chunks can be uploaded in parallel, which can improve the overall upload speed depending on the internet connection. The simplest way to achieve resumable uploads is similar to direct uploads to S3 that we already talked about. It's just that instead of using that, the browser is using the multipart upload feature from S3, and it also needs to communicate to some. It also needs some endpoints in your application, but the upload goes directly to the cloud service. And API provides a plugin that does that, and I also created a gem which knows how to which is compatible with the which implements the endpoints that this API plugin needs. Now this solution is kind of coupled to the storage. So if you are using, for example, Google Cloud Storage, it might be more difficult to make it work. And also, if you are uploading, if you want to make it more language agnostic, it's kind of like you need to have JavaScript on the client side, so iOS and Android not really, and also there's limited language support for the backend part that needs to be done. There is the same company that created API also created a generic HTTP protocol for resumable uploads that's called TAS.io. And the word HTTP protocol sounds a bit scary, but it's just a collection of HTTP headers and a URL that both the client and the server needs to know, need to abide by, so that together they can achieve the resumable upload. Because this protocol is generic, there are numerous implementations for it, and so you have much more options. And the way that it works is instead of the application just providing some endpoints for information, the uploads this time they go directly through your app or like through the TAS server, and then the TAS server then translates these uploads to the specific storage service API. So the TAS server is the one that's configured with the storage, and the TAS client doesn't know where the files will be stored. It only knows how to communicate with the TAS server. Surprisingly, there is also an API plugin and a gem that make these two things work together. So it's like, regardless of which option you choose, it's kind of like it's always a similar way to implement, and it's really streamlined and easy. Let's now see this in action. So the resumable upload, it looks similar to regular upload, but we can see that API knew that the upload was resumable, so it added the pause button. And then when we click it, the HTTP request is terminated, but the server saved some data already on the server. So when we click it, the upload can automatically resume with a new upload request. And it can even happen like if our whole upload terminates, which I will simulate here by clicking on the X button. The browser in local storage stores the status of the file, so the upload can resume after that, and everything is completed. So to recap the resumable uploads, it really helps. It can really improve the user experience when the user is uploading. Your user is uploading large files. One way to implement is to use S3 multiple upload API, which is like the simplest, and it's nice that the upload goes directly to your cloud storage service. An alternative way is to use a more generic TAS protocol, which has numerous implementations in numerous languages. Here are some useful links for what I just talked about, and that's it from me. If anyone has questions, yes. Happy to answer.
Hello, thank you for the presentation. I'd like to ask you about the processing on the fly part, because it seems very nice because it doesn't load the server up front, but it seems to be prone to DDoS attacks because the attacker can ask for several versions of the same uploaded file and clock your server effectively. How to defend from this situation?
Great question. So the Shine feature, or like and many other on-the-fly processing features in other file gems, they sign the URL with a secret that's only known by the server. So only the server can generate a valid URL. And the URLs that the server generates will likely then be cached into your CDN, and then the attacker isn't able to generate any other URL because then the signatures won't match.
Thank you, that's great.
Here.
So I think there's one problem with asynchronous approach for file uploads. You can have a user that submits a huge file and then just doesn't continue with the metadata. You can't make asynchronous file uploads transactional. How do you deal with it?
So there is a mechanism provided by S3 that when you are requesting the upload parameters, at the same time you can pass like a limit to the file size, so that when the user and then on the endpoint that generates the upload parameters, you can say like, okay, you cannot generate a larger file. So that, and there is also a mechanism of validating, of constraining the content type. So that provides some kind of mechanisms which, although are not generic, it differs from service to service. But it's more challenging than expected to prevent users from uploading large files to your cloud service. Yes, I don't have a good answer for that. Yeah, I will try to find more about that, and if you have any more questions, feel free.
Thanks, but I actually was referring to a bit different thing.
Yeah.
When file is first submitted, but then you don't continue with the metadata. You submit the image, but don't type the title and everything else, making the image actually useless.
Yes.
So is there a way, for example, to have the image expire after a few minutes?
Yes,
if
yes.
Nothing is submitted then?
Yes, okay, now I understand. So yes, the Shrine actually has a mechanism where it requires you to use a temporary and a permanent storage. When we were generating these endpoints, there was this cache symbol, which meant like upload to temporary storage. And then on the S3, that can be a separate directory, which you can configure, for example, S3 to automatically expire old files. And then that that directory is separated from your main files that are actually attached to records. So these files that are not attached anywhere are called orphan files, and Shrine tries very hard not to allow that to happen.
Thank you so much.
Okay. Okay, here.
How would you suggest testing this? I mean, in the test mode, we would like to have, instead of S3 storage, maybe local storage. Is it easy to implement using Shrine?
Yes, there is a great open source tool called Minia, which responds to the S3 API. So if you are using S3, you can just point the SDK to your Minio server, and then your Minio server would store the files locally. And that way, during your tests, everything will still think it's communicating with the S3 API, but actually the files are just storing locally. The only thing you need to do is to run that Minio server as a separate service. Yeah.
Okay. And would it be easy to use like private VPS instead of S3 as well?
I haven't researched that. It's probably possible because there are there are many. I think there might be tools that knows how to proxy the S3 API into something that you want, but I don't know like a specific tool that would do what you ask.
Okay, thanks.
Here.
Hi. ImageMagick has known security vulnerabilities in the past. libvips is also is better, but it was not built with security in mind, security first perspective. There is image flow project. Have you considered adding this to image processing GEM?
I would love to add it, like when it's at the moment. The only problem is that there aren't Ruby bindings that are ready, and I would like if someone else would create the Ruby bindings. Hopefully, the author. I think that it was in the plan, but I was following and have backed the image flow project before, and I found it really exciting, and I would like. As soon as someone creates Ruby bindings, I would love to add support to the image processing gem.
Thanks.
Okay, I think that's all. Okay.